We're under our fifth lesson in the Foundations unit, and it's on the subject of significant figures. So this deals with the issue of how many digits do you write an answer to in a science laboratory experiment or calculation. Okay, so let's talk first about rounding. Rounding is the process of limiting the number of digits after the decimal point. So an example, round the following number to 3 significant figures, and we're going to talk about that. But just a quick definition, it is the first 3 digits from the left. So 3, 4, and 7. Those would be that would be 3 significant figures. So if the next digit to the right of the 7, that's the third significant figure, and that's the 6 in this case. If that's less than 5, then the 7 would stay as a 7. If that digit to the right of the 6 is 5 or greater, then the 7 rounds up to an 8. And we can see that 6 is 5 or greater. So that's going to make that answer 3.48. That 7 is going to round up to an 8. Significant figures, which we just shortened to Sig Fig, indicate the precision of a measurement. In math terms, they provide a set of rules for how many digits you should use in your answer based on the precision of your laboratory measurements. So let's take an example here. Let's say you measured the dimensions of a room. Now you measure the width of the room with a laser device that's precise to 1/10,000th of a meter. So that's the 5.2143 that you see there in the blue box. The length of the room you measure with an old meter stick, and you measure it much less precisely, so you only measure that to 8.1 meters. To obtain the area, the formula for area is width times length, so you would multiply those two numbers together. And what you would come out with on your calculator would be 42.23583 square meters for the area of that room. So significant figures indicate the precision of a measurement. So that's what you would get, that area down there on the bottom. So this value of 42.23583 square meters indicates a level of precision for the measurement that's misleading, because the length measurement could have actually been, if we're saying it's 8.1, it could have been anywhere from 8.05, between 8.05 and 8.14 with rounding. In other words, if it had actually been 8.05 and you wanted to round it to the first place after the decimal, you would have rounded that to 8.1. And if it had actually been 8.14 and you wanted to round that to one place after the decimal, you would have rounded that down to 8.1. So both of those measurements would have resulted in 8.1. So you can see it could be anywhere in that range. So we can't really state that measurement is exactly 42.23583. So this means, let's just do the math on that. This means that the area could have ranged between 41.975 and 42.444. That is, if we had multiplied the very precise measurement of the width, 5.2143, by 8.05, we would have gotten 41.975. And if we had measured the width 5.2143 by 8.14, we would have gotten 42.444. So that's a not insignificant range of numbers that actually could have been the actual area of that room could have been. So the rules of significant figures limit the number of digits you can use in the answer to 2. So the answer is, to express the area to the correct number of significant figures, you can only use 2 significant figures, and we're going to learn the rules for that in this lesson. So the area would be 42 meters. You can't express it any more precisely than that. Again, because that length measurement is only done to 2 digits, 8.1, 2 significant figures. So your final answer can only have 2 significant figures of 42 meters. So here are the rules for significant figures. 1. All non-zero digits are significant. So 1 through 9 are always significant. Zeros to the left of the leftmost non-zero digits are never significant. Zeros in between non-zero digits are always significant. And zeros to the right of the rightmost non-zero digits are significant if there's a decimal point, and not significant, or you might just say uncertain, if there's not a decimal point. So let's just look at some examples, and this will make more sense. So that the number 326. So how many significant figures? The answer is 3. All non-zero digits are significant. So there's no zeros there, so everything is significant there. 3045. How many significant figures? 4. A zero between non-zero digits is significant. So the zero between the 3 and the 4 is always significant. A zero in a position like that. 6020. And there's no decimal point. So that's 3 significant figures. No decimal. So the trailing zero, that's the one furthest on the right, is not significant, or it's uncertain. Some books will say it's not significant. Some will just say it's uncertain. Let's go with some more examples. How about this one? That's 5 significant figures. Leading zeros, that's ones to the left of the leftmost non-zero digit. So the leftmost non-zero digit in that number is 2. Any zeros to the left of that 2 are never significant. Don't try to reason this out, why this is, or understand why that is for right now. Just understand the rules. Just follow the rules. 10,000. Well, if there's not a decimal there, we're going to say that that's only one significant figure. Trailing zeros are not significant or are uncertain if no decimal point. How about this one? 8 significant figures. All zeros are significant. So 3 of the zeros are in between non-zero digits. The 4th zero is the one on the right, and that is significant because there is a decimal point there. So that's significant. Again, commas have nothing to do with anything other than to make a number easier to read. How about this one? 4 significant figures. Leading zeros, that's to the left of the 1, are never significant. Trailing zeros to the right of the 1 are significant because there's a decimal point. So multiplication, the number being multiplied are called multiplicands, and the answer is called the product. So the rule for multiplication, they're pretty simple. The product should contain the same number of significant figures as the multiplicand with the least significant figures. So here's some examples. 2 times 4 equals 8. The significant figure, it's not the number of significant figures, it is what is the significant figure answer is 8. 2 has 1 significant figure, 4 has 1 significant figure, so the answer 8 can only have 1 significant figure. Well, that one's pretty obvious because that was going to be the answer anyway. So 2 and 4 have 1 sig fig, so the answer has 1 sig fig. What about 31 times 23? Now, this one is actually one of the trickiest ones for students, okay? The answer is going to be 710. So 31 has 2 sig fig, 23 has 2 sig fig, so your answer can only have 2 sig fig. And what some students think you should do in this case is just lop off the 3, and the final answer would be 71. But no, the answer is going to be a number near 713. It's just a matter of the precision. That's showing too many digits of precision, 713 is. So you are simply going to round that 1. Using the 3, you're going to round the 1. And since a 3 is going to round back down to the 1, then you have 7 and a 1, and that 3 turns into a 0. All right, this is maybe the trickiest one that you're going to see. So each of the multiplicands has 2 sig fig, so the answer is limited to 2 sig fig. The last digit 3 should be rounded down. All right, what about these? So what you're seeing there is the calculator answer of multiplying those two numbers. The calculator answer would be 0.3432. So the Sig Fig answer, see if you can come up with that. It's going to be 0.34. The 0.104 has 3 Sig Fig and 3.3 has 2 Sig Fig. So the answer is limited to 2 Sig Fig, the multiplicand with the least number of Sig Fig, and that's the 3.3. The answer is rounded down to 0.34. 314 and 0.204. On the calculator, that's going to give you 64.056. So what's the Sig Fig answer going to be on that? Think about it. 64.1. Each of the multiplicands has 3 Sig Fig. So the answer is limited to 3 Sig Fig. The 5 rounds the 0 up to a 1. How about this one? Now this one is going to mess with you a little bit. You're going to say, how can this be? But what do the rules say that the number of Sig Figs should be? The answer is 40,000. The 5 limits the answer to 1 Sig Fig. The 2 in 42,735 is rounded down to a 0, and all remaining digits are zeros. Let's do another. So that's going to be your calculator answer will be 0.00104. The answer is limited to 2 Sig Fig because of the 0.10. 0.10 is 2 significant figures. So your answer is limited to 2 significant figures. So in 0.00104, where are the 2 significant figures furthest to the left? That would be the 1 and the 0. So you're going to use the 4 to round the 0. It's either going to, if it's a number greater than 5, it's going to round it up to 1, but it's not. It's a number less than 5, so it's going to round it back down to 0. So your 2 Sig Fig there are the 1 and the 0 furthest to the right, that last 0. So 0.10 limits the answer to 2 Sig Fig. The 4 is rounded down to 0. The 1 and the trailing 0 are the only significant figures. How about this one? 42. The measurement example on the earlier slide, that's what this is. Those are the numbers we did earlier on that room example. The 8.1 limits the answer to 2 Sig Fig. So the 2 after the decimal in 42.23583 is rounded down. So that leaves the answer as just 42. Now, a point here, you don't put 42.0 because if you did that, that 0.0 would be an additional significant figure. That would be 3 significant figures. So you have to leave it simply as 42. Okay, now we're going to do it with division. The rules are the same. A division, you have a divisor, that's the number on the bottom, and a dividend, that's the number on the top. Whichever one has the least number of Sig Fig, that's going to determine how many Sig Fig in the answer. So what's the Sig Fig answer for that one going to be? Think about it. And it's going to be 1.2. 2 digits in the denominator set the answer at 2 Sig Fig. So you're going to have 1.15. The 5 is going to round that second one, the one after the decimal point, up to 2, and it's going to make that 1.2 that would be 2 significant figures. How about this one? 3.4. 3,400 has no decimal and has 2 significant figures. 987 has 3 significant figures, so the answer is going to only have 2 significant figures, so that's going to round to 3.4. And when rounding, you only use the digit immediately after the last significant figure. So that 4 in the middle of 3.444, that's the one that's going to round the 3.4 either up to 3.5 or back down to 3.4, and in this case it's at 3.4. This one, 200. The 0.8 is 1 sig fig, so only the 2 in the final answer is significant. The 3 rounds the 2 down. In other words, it stays at a 2. It doesn't round up to 3. There is no decimal in the final answer, making the 00 not significant. Okay, so look at 200. In the answer 200, there's only one significant figure because there's no decimal there. All right, it's a little tricky. It just requires some practice, and we'll do plenty of practice on these in class. In the next lesson, we'll talk about significant figure addition, and also we'll get into measurements in the lab. How do you read lab equipment to record the correct number of decimal places?